Alright, for section 4.1, I'm going to run through 4 problems. I started this already, I guess, a little bit, but I'm going to convert this, which is degrees, minutes, and seconds, into decimal degrees, and then I'll take one that's in decimal degrees and I'll convert that into degrees, minutes, and seconds. The other thing I'm going to take a look at, and this is the harder part of this chat or this section, and so you want to make sure that you look at it. This is actually problem number 103, I believe it is, from your homework. I don't normally do problems from your homework, but this is one that I'm doing. You'll want to make sure that you are able to figure out how to set up angular and linear speed. You'll definitely want to take a look at problem 101. It is the same sort of setup, but there's a lot of conversions that they make you do, which makes it a lot harder. This one's got one conversion, but you'll see. So make sure that you are comfortable setting this one up, and then we'll probably take a look at 101 in class the next day, but try to see if you can get that one. And then the other one is one of the last 2 problems. It's a windshield problem. You'll see when you get to it. It says it rotates 145 degrees. The wiper mechanism is 30 inches. The windshield wipes over a distance of 21 inches, and it wants you to find the area covered by the wiper. So let's start with converting from degrees, minutes, and seconds into decimal degrees. So when you're looking at the degree part of it, you want to keep that number. If I'm changing this into a decimal, like for example, when I look at this one, this is actually the degree. The decimal part of this comes from the minutes and seconds. So I just have to remember, how do I convert 16 minutes into degrees? If you think of degrees like you would hours, it kind of makes sense. There are 60 minutes in an hour. So if I divide 16 by 60, it'll convert it into a degree. Hopefully that makes sense. If I take the number of seconds in an hour, there's 3,600. So if I take 20 and divide by 3,600, that will convert these into decimals, and then I just have to add them together and put it on the end of 408. So it's using the conversions that we looked at in class. So it's taking 16 divided by 60, and you probably want to write out as many of these as you can. Obviously this 6 is repeating for a little while, so if you wrote a few of them, you'd be fine. If you take 20 divided by 3,600, and again try to write that out as far as you can. It looks like you just have 5 repeating over and over and over. So use the same number of decimals. I've got 5 here, I've got 5 here, so I'm going to take 0.26666 plus 0.00555, add them together, and that would be the decimal. It's going to be negative 408.27221 degrees. So that converts it into decimal degrees. Now there's an easier way that I showed you in class, and I'll show it to you again in case you forgot how to do that. But if you want to type that whole thing in and then just hit enter, you can do that. You have to remember where to go. So I'm going to start by typing in negative 408. Alright, now to figure out where do I get that little degree symbol, remember that little purple button you see here, it says apps. Just above it in blue it says angle. That's where you want to go. So you have to hit second, apps, and then you can see number 1 there has the degree symbol. So either hit number 1 or hit enter on number 1. That'll put the degree symbol on there. I'm then going to type 16 or whatever the number of minutes you have. Go to the same spot, go to second, apps, and if you look, you can see it's number 2 that you're looking at for the minutes, so either hit 2 or go down to 2 and hit enter. And then you want to hit 20, and the problem is if you go to second, apps, where we've been going, I don't see the seconds anywhere on here, and that's because they're not in here. I don't know why, but what you need to do is if you look at your calculator and you look at the plus sign, you can see just above it in green, you see the little second symbol. So what you have to do is have to hit alpha and then the plus sign, and that will give you the minutes, or sorry, the seconds. And now I have all of that entered in. All I need to do is hit enter, and it'll do the conversions for me. So should you know how to do that? Yeah, you should know how to do that, but you're going to have a calculator in order to do this anyway. So realistically, you could just do that. What I would probably ask to see for work if this was on a test is just to write those 2 things out. Then you could simply just plug it in your calculator. Alright, the same thing is true for this one. I can actually just type this whole thing into my calculator and hit enter, and it'll figure this out for me, but I'll do the conversions for you first. What you want to do is the opposite is what you did here. You're going to sit and you're going to multiply. So I want to take the number that's in front of the decimal. That is going to be the number of degrees that I have. I don't have any, so I know I'm going to have 0 degrees, And now I take the decimal to figure out the minutes and seconds. I'm going to take that decimal, whatever it is, however long it is, and I'm going to multiply it by 60. And what this is going to do is this is going to change it into minutes for me. So 0.7865 times 60 is going to give me, and I would not round this, this is going to be 47.19 minutes. Well, what I want is just the whole number part of this. I'm going to say that I have 47 minutes, and now I'm going to take the decimal and do the same thing I just got done doing. I'm going to change this into seconds. Right now it's in minutes. If I multiply it by 60, since there are 60 seconds in a minute, it will convert it into a second. So now I take 0.19, multiply by 60, and it gives me 11.4. And then typically I would round this, so I would just say it's 11, whoops, this is supposed to be minutes. It's supposed to be 11 seconds. You could say 11.4. You want to round it, that's fine. You don't want to round it, that's fine. Either way, it's fine. The book, I believe, rounds it like this, so you can do that. That's why I do it that way. All right, if you want to just type it in your calculator, which is obviously a handy little thing, you just need to type that decimal in, 0.7865. You're going to want to go to that same spot that we did to find the degree symbol and the minute symbol. You want to go to second, and then hit the apps button, that purple button. And then look at number 4 there, DMS. That stands for degrees, minutes, seconds. Go down to that, hit enter again, and you can see it gives you the exact same answer that we got. And it doesn't round it. I would just round it. So very easy to do, especially if you've got a calculator handy, which you're going to need to because these numbers are not going to be very fun to do by hand. All right, so those are the first 2 problems. Hopefully those are quicker for you. The 2 where you probably have some issue is doing the story problems. Can be a little tricky setting them up sometimes. So looking at the first one, again, this is number 1, I think 103 in your textbook. It says a 7 1/4 inch circular power saw rotates at 5,200 revolutions per minute. It wants us to find the angular speed of the saw blade in radians per minute, and then find the linear speed in feet per minute. All right. Well, one thing that this problem doesn't do a very good job of is when you look at this and you say, is this the radius or is this the diameter? That's actually the diameter. Doesn't do a very good job of telling you that. So you're going to need to divide that by 2 to know that your radius is actually 3.625. So one thing it doesn't do a very good job on that problem is telling you that. That you'll have to know. All right. Now remember, anytime you're doing any of this angular speed, linear speed, you want to do 3 steps. Step number 1, always find the number of rotations. And of course they did that for us, so that was nice of them. They told us what the number of rotations or revolutions were. Number 2, the reason I want that is I'm going to use that to help me find the angular speed. So now this goes right to what we were doing on the notes. Why do I want that? Well, the angular speed is equal to 2 pi times the number of rotations divided by time. And since the time in the story problem was minutes, and what they're asking me to find the angular speed is minutes, realistically that means the time is just 1 and I can ignore it. So it's really 2 pi times the number of rotations, and then a possible unit change or conversion if you have to. And then after you find the angular speed, the last thing you would find is the linear speed. So if you were just asked to find the linear speed, you have to find all 3, unfortunately. But the linear speed takes the angular speed and multiplies it times the radius. So it's simple enough in terms of the steps that you have to go through. It's number of rotations, multiply that by 2 pi, possibly make a unit conversion, and then multiply by the radius and again possibly make a unit conversion. And you're going to see in this problem, we're talking about inches, and in the linear speed they ask us to write it in feet. So there's going to be a unit conversion for that one. Alright, so step 1, find the number of rotations. Well, they did that for us. There's the number of revolutions per minute. Good, we got that. For letter A, it says find the angular speed. I need to take the number of rotations, which is 5,200, multiply it by 2 pi. Remember, this is the little goofy symbol that we saw for angular speed. So I'm going to take the 2 pi times the number of rotations. Makes sense if you think about it. 2 pi is 1 trip around the unit circle. We're doing it 5,200 times. And then I'm dividing by the time. It was in minutes to begin with. They want it to stay in minutes. So I really just divide by 1. So my angular speed is going to be 10,400 pi. And that's an exact answer. Or if you look in the book, they give 32,672.56 radians per minute. I believe they give both answers, but they're the same thing. Alright, so now that I figured out letter A, let's move on to letter B. It wants the linear speed. Well, good news. I just take the angular speed, whichever one you want to use, and multiply it by the radius. So I'm going to take 10,400 pi, and I'm going to multiply by the radius, which we said was 3.625. Alright, and now the only thing here is that this is in inches. I need that to be in feet. So ask yourself, how many inches in a feet? We know there are 12, so I'm going to have to divide this by 12. If it wasn't for the unit conversion, it would be as simple as multiply it by the radius and you'd be done. So I'm going to type this in my calculator, 10,400 pi times 3.625, the radius, divided by 12, and it gives me an answer of 9,000, approximately, 869.84, and this would now be feet per minute. So the only thing that's making letter B maybe a little more challenging if you understand these steps is that you have to make that little conversion from inches to feet. Other than that, it's a fairly straightforward problem. I wish they were all nice and easy to set up. 101, the setup is just like that, but there's a lot of converting from feet to miles or minutes to seconds. I can't remember exactly what it was, but something like that. And like I said, we'll take a look at that. And then I think it's the second to last problem you have in the homework looks almost identical to this. The numbers have changed, but the right idea. And it can be very tricky in terms of how to set this up. So definitely take a look at this one. It says a car's windshield wiper rotates 145 degrees. Total length of the wiper mechanism is 30 inches, and it wipes the windshield over a distance of 21. That's a little confusing in terms of what are they talking about. Well, here's what they're looking at. You probably know that when your windshield wiper is going in your car, your parents' car, that you have something like this, and it actually wipes this distance here. You know, that distance down here doesn't actually get wiped. Well, here's what they're saying. So let's say this is the wiper. What they are saying is that this is 145 degrees, what is rotating. They're saying that the wiper mechanism, they're saying from the point where it's attached to the car to the end, that is 30 inches. And then it wipes over a distance of 21 inches. That's the actual part that's being wiped here. And that can be a little confusing in terms of what they're saying. So that's what they're getting at. That's the picture that you would be looking for. If that helps you out, great, then you can start to go from there. Now if you look at it, you're looking at the area of a sector. And when we looked at the area of a sector in the notes for 4.1, we said that the area of a sector is equal to 1/2 times r squared times theta. And we said that you have to be careful because theta has to be in radians. So if I put 145 in there, it's not going to work. Alright, so the idea is how do I find the area of what it wipes, because I do not want this? Well, what I'm going to do is I'm going to find the area of the entire thing, and then I'll just subtract out this. So I'm going to find the area of all 30 inches of it. So the area is equal to 1/2 times the radius. If you continue to swing this around, it would be a circle and its radius of 30 squared times, it's 145 times pi over 180. Remember, that's how I converted into radians. So I can go ahead and figure that out. Now obviously I can plug that in my calculator and I can figure out the answer, and we'll do that in a second. Now that's going to give me the area of the entire thing. I actually do not want this. So I have to subtract it out. Well, what's that distance? If the whole thing is 30, this is 21, what's left? Well, I'm subtracting out a radius of 9. So if I found that little area right here, this is going to be 1/2 radius of 9 squared. The angle is still the same thing. It's still 145 pi over 180. And now I'll figure out what this is, I'll figure out what this is, and I'll just subtract the two. So 30 squared, or 900, divided by 2 times 145 pi divided by 180 is going to give me approximately 1,138.8, let's say 3. And then figuring this one out, if I have 145 pi, and I divide that by 180, multiply by, I know that's 81, divide by 2, that's going to give me 102.49, and now I just need to subtract them. So it's 1,138, okay, 1,138.83 minus 102.49, and my final answer would be it wipes over an area of 1,036.34 inches, square inches. All right, that is your homework help for section 1.4. Feel free to come in and ask for help if you need to.